Hi everyone. Today I'm going to present about the horror movie detection by using the Movie Dataset API for our project CZ115, Data Science and AI. Here's our content. First is our problem statement, approach, how we generate dataset, what kind of model we are using for our cases. For example, the CNN model and transfer learning. And we also train with the transfer learning with the multiple classification. For the problem statement, have you seen the horror movie before? Basically I'm a big fan of the horror movie. Every time I pass by the movie theater, okay, this is definitely a horror movie because all the horror movies share the same, almost the same statistic. For example, the dark scene and the ghost face and some of the very bloody environment. And that is how humans tell this is a horror movie from the poster. But how about our machine learning model? And we also want to try to train the machine learning model to tell whether the poster is a horror movie or not. For our approach, we are trying to get all the data from the TMDB dataset. It's get around 10,000 raw movie data and also the image data. And we try to split the data into training and the testing set, as what we usually do for machine learning. And we also try to apply different methods for the convolution neural network and the transfer learning and the multiple data set. First step is our data set preparation. We read the Cloud to get all the popular movie and we got all the information about the jury IDs, poster pass, titles, and IDs. We also download the image accordingly. And then here is our dataset split. We have almost 8,000 of the long horror movie, and we have around 1.8K of the horror movies. Because all these movies contain the Gary ID of 27. So we just label the movie contain the number of 27 as true, and the others are false. Here's how we label the data to generate the label dataset. Okay, next is how we prepare the dataset class for our training. Basically we will inherit the dataset from the PyTorch framework, and we just do some data splitation and try to read the CSV and get all the information here. Try to make it as usable by the data loader for the PyTorch. And then we also find out some of the dataset in our Cloud. We have some of the data is have multiple information, like the duplicate information, and then we also have some of the movie doesn't contain the poster image, so we need to clean them up. This is how we do the data cleaning part. Till now we are trying to split the data to training set and testing set. We have around 90% of the training set and the 10% of the testing set. Okay, so next I will tell you about our first approach is to using the convolution neural network. What is a convolution neural network? First, for my understanding, we would say we are using a small sliding window to slide through all the image. And this sliding window will generate a feature, it's a feature map. And this sliding window we can set a different value. For example, we can set different boundary and different value is set. So we can slide through the image and generate different features. And after the sliding window, we are trying to use the max pooling to amplify the feature information. And then we are trying to use the sliding window again. And then we try to use the max pooling again. After that, we will flatten all the channel information and become a linear neural network. And then we will try to shorten the size of the perceptron. And then in the end, we will get only two class, which is true and false in our cases. For the activation function, we are trying to using the ReLU function because the reason is we have read through the document from the PyTorch. It mentioned ReLU activation function usually provide better performance. So we just use the ReLU function in our cases. We have tried the convolution neural network method, but first is we have trained the model for a long time, and the performance and the result is not as good enough. It's around 60%. So we decide to don't use that method. We find a better method. It's called transfer learning. So what is transfer learning? Transfer learning basically is trying to implement the previous knowledge it has learned from the other neural network and trying to learn some similar things to extend its features. So here is like generally how the transfer learning work in our PowerPoint. So in our case, we are trying to borrow the model from the RazorNet. Okay, this RazorNet is a very famous neural network by the research scientist He Kai-Ming. It contains a very specific feature, a special feature is called a Razor block. It will guarantee that the performance result will be definitely better than the previous Razor block because they are trying to use the XOR function here. And also, in our case, we are trying to use all the knowledge it has learned from the ImageNet. So in our code, we can explain here. At first, we are trying to use the pre-trained model for the RazorNet and get all the value from there. and then we try to flatten the model, the 17 layer. The first 17 layer, we try to use previous knowledge, and then we connect to another linear network at right after the 17 layers of the ResNet. After that, we are trying to use some batch normalization, and we also do a dropout because this model ResNet maybe is too large for binary cases classification. So to prevent the overfitting, we need to drop out some of the data. This is called the Ballumier programmatic function. Could be like that. And then after that, we are trying to, after the dropout, we try to connect another linear layer, which will drop our processor size to 2, which fit our cases. For here, we try to use the optimizer with SGD with the momentum. That's a stable one. And also trying to use cross entropy loss here. In the end, we get a result almost 90% of the accuracies for the testing dataset. You can see it's a very good. It almost can tell all the poster properly. But here come a very interesting fact. You can see the below 2 poster. You just tell which one is a scary one. It's much more scary. We can say definitely it's the right one because have a very have a dark scenes and also have a ghost face behind the tree. But left one is not so scary because we can see the labeling, the Jerry labeling. The red one, the 27 is appear at the first element of the array, and the left one, the 27 is appear at the last one of the array. So I would say we can try to do a multi-class classification because we try to label some of the movie, like if the first element is 27, then we will say, oh, it's a very horror movie, then we label it as 0. And then for the others, like include the 27, we will label as 1. It's a scale of horror movie, but not so scary. Maybe the last one will be common movie, as usual. So here is how we label the data. We just split this data and then we try to do some of the multi-labeling training. Okay, here is how our code looks like for the multi-class classification. We also do the same thing. We're trying to do the data augmentation to prevent the overfitting, and also trying to generate more features. And also we do some, this is how our training process look like. We have to do the same thing for the linear layer right after the ResNet first 17 layer. And then we'll do some batch normalization, and we do some dropout. And then in the end, we'll generate 3 perception with 3 class, which fit our cases. This is how our results look like. In the end we get around or close to like for the accuracy maybe it's 85% of the correctness. So for conclusion, here is what we have learned for this project. We have learned the pre-processing of the data and the labeling, and also we try to do some self-learning for the PyTorch framework and the convolution neural network, and also some of the image recognition and classification using the ResNet and the transfer learning methods. That's it, what we have learned for this project. Thank you so much. Here is all our reference. Thank you.